Kate, I'm going to go ahead and get started just with problem number 1. This is your Unit 5 review. If you don't have your copy of the review, I recommend you go to my website and print a copy so you can follow along. We're starting just with problem number 1, and the first thing I need to do is to know which type of factoring it is. So I know it's a quadratic because the highest exponent is a 2, so it's got to be quadratic, and then if I look here, I don't have any a value here, so a is just equal to 1. So that means this is an a equals 1 quadratic, so I'll factor this by finding my AC and my B. So AC is 1 times -5, which is just -5, and B is 4. So I need two numbers that multiply to -5 and add to 4. So the only numbers that multiply to 5 are 1 and 5. So I need to figure out which one should be negative to add to 4. And if I have a -1 and a +5, that adds to 4. Because a is equal to 1, then this essentially is the hardest part of the process. I can just rewrite this, and it's n minus 1 times n plus 5. Where if a were not equal to 1, then I would need to use these numbers to split up my middle term. Then if I come back and look at the instructions, this says to factor and then solve. So I need to make sure I solve these. So if I set n minus 1 equal to 0, I can add 1 to both sides, and n equals 1. If I set n plus 5 equal to 0, I can minus 5 from both sides, and n equals -5. So my solution in this case is n equals 1 and -5, and then I'm done. My next problem, number 2, is n squared minus 9. So this is a difference of squares. I know that because there's no b value. Sometimes there will be no c value. In that case, it's probably a greatest common factor. But in this case, we have no b value. So I'm going to start with n squared, and since I don't have a b, my b is 0, so plus 0n minus 9. And then I can factor it just like I factored number 1. So a times c is a -9, and b is 0. So two numbers that multiply to -9 and add to 0 are 3 and -3. So this factors to n plus 3 times n minus 3. And then if I set each of these equal to 0, so I have n plus 3 equals 0 and n minus 3 equals 0. So on this one, if I minus 3 from both sides, n equals -3. This one, I add 3 to both sides, so n equals +3. So in this case, my solutions are n equals -3 and 3. And there's my solution. Number 3 looks very similar to number 1, the only difference being there is a number in front of my n squared. So this is factoring a quadratic where a is not equal to 1. So on number 3, I'm going to start it the exact same way. So I have my a times c is 7 times a -10, which is -70, and b, which is -3. So two numbers that multiply to -70 and add to -3. So 7 and 10 multiply to 70, and I've got to figure out which one needs to be negative for this to be a -3. If I have a -7, -7 plus 10 is a +3, so that doesn't work. But if I have a -10, 7 plus a -10 is -3, so that does work. Now, if a were equal to 1, then I could just immediately rewrite this, n plus 7 times n minus 10. But since a is not equal to 1, I've got to go a little bit further. So I'm going to start with 7n squared. Then I'm going to take this middle term and split it up using these two numbers. So I have plus 7n minus 10n minus 10. And then I can just group both sides. It's now 4 terms, so I can factor by grouping. So I'm going to group that side and group this side. So over here, I can factor out a 7, and I can also factor out an n. So 7n squared divided by 7n, I just have an n left. 7n divided by 7n is 1, so n plus 1. And then over here, I can pull out a -10. You always want your n to be positive, so if it's negative, you're going to want to pull out that negative, factor out that negative. So I'm going to factor out a -10. So -10n divided by -10 is just n. -10 divided by -10 is 1. So I have n plus 1. So now my parentheses match, which is what I want to have happen. So this factors to n plus 1 which is what it's in parentheses. And then I'm left with 7n minus 10. So I have 7n minus 10. And now if I set each of these equal to 0, I'll get my solution. So I have n plus 1 equal to 0, and 7n minus 10 equal to 0. So over here, I can minus 1, and n equals negative 1. Over here, I can add 10, So I have 7n equal to 10, and then to get rid of the 7, I'm going to divide both sides by 7, and n equals 10 over 7. So in this case, n equals negative 1 and 10 over 7. And again, the reason I'm going this far is because the instructions say to factor and to solve. So if we're solving, we want to get the variable by itself. Number 4 also has two terms, just like number 2 did. The difference is this has an A term and a B term. It doesn't have a C term. So in this case, I can start by just taking out my greatest common factor and then see if I have to go further. So with 4 and 14, I can pull a 2 out of both of those. And then r squared and r, I can pull out 1r. So if I do 4 divided by 2, I have 2 left. R squared divided by r, I have 1r left. And then I have negative 14 divided by 2 is negative 7. And then r over r just cancel out to 1. So I have 2r minus 7. And if we look now, I don't have any r squareds anymore. I have 2 factors. So right from here, I can just set my 2 factors equal to 0. So I have 2r equals 0 and 2r minus 7 equals 0. So on this side, I'm going to divide both sides by 2. So 0 divided by 2 is just 0. This side, I'm going to start by adding 7 to both sides. So 2r equals 7, and then divide both sides by 2, and r equals 7 over 2. So these are my 2 solutions. R equals 0 and r equals 7 over 2. And those were all the ones, the first 4 that asked me to factor and solve. My next set of instructions just says to factor. It doesn't say to solve. So I'm going to start by just factoring. So I have 2x to the 4th plus 13x squared minus 7. So it looks like a quadratic, except I have a 4 here instead of a 2 here. So this is a quadratic type factoring. So I'm going to start it the same way. So my a times c is 2 times negative 7, which is negative 14, and my b is 13. So two numbers that multiply to negative 14 and add to 13 would be 14 and negative 1. 14 times negative 1 is negative 14. 14 plus a negative 1 is 13. Now, because a is not equal to 1, I've got to go to that next step. So I have 2x to the 4th, and then I'm going to split this 13x squared up using these two numbers. So I have plus 14x squared minus 1x squared, and then just minus 7. Now I have 4 terms I can factor by grouping. So I'm going to factor each side. So over here, I can factor out a 2 and an x squared. So then if I factor a 2x squared up to 2x to the 4th, I just have x squared left. And then 14 divided by 2 is 7, and then x squared divided by x squared cancels out and is gone. Over here, remember, I don't want my variable to be negative, so I need to factor out that negative 1. So then I'm left with x squared, and then negative 7 divided by a negative 1 is a positive 7. So now my parentheses match at x squared plus 7. And then if I take those out, I'm left with 2x squared minus 1. So if I look at my different options over here, I have x squared plus 7 and 2x squared minus 1 is B. All right, number 6, at the very beginning, I noticed there's 4 terms. And when there's 4 terms, in most cases, I factor by grouping. So I'm going to group these two and group these two. So with 20x cubed and 16x squared, the greatest common factor is 4x squared. So 20 divided by 4, I'm left with 5, and then x cubed divided by x squared, I have one of my x's left. Then 16 divided by 4 is 4, and x squared over x squared just cancels out, so I'm left with 5x plus 4. Then I look at these two, the greatest common factor is a 3. And then I have 15x divided by 3 is 5x, and 12 divided by 3 is 4. So my parentheses match, so to start, I have 5x plus 4. And then I'm left with 4x squared plus 3. And if I look at my options, that matches A perfectly. So number 6, the solution is A. On number 7, I am factoring a sum or difference of cubes because I have an x cubed and then a number. So I need to rewrite this as x cubed plus another number cubed. So if I put the cube root of 64 in my calculator, I'm left with 4. So this is the same as x cubed plus 4 cubed. Now, on your test, I will give you this formula, but the formula says that a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. So if I come back over here, my a is equal to x, and my b is equal to 4. So if I come back to my formula, I'm just going to plug an x in wherever there's an a, and a 4 in wherever there's a b. So it starts with a, so I have x plus b, which is 4. And then I have a squared, which is x squared minus a times b, so x times 4, or 4x, plus b squared, which is 4 squared, and 4 squared is 16. So then I come back to my options and I see again I have part A, which is x plus 4 times x squared minus 4x plus 16. Number 8. I, again, have 4 terms to start, so I'm probably going to factor by grouping. But I also notice that 21, 9, 21, and 9, they all have a greatest common factor. So while you could just group from the very beginning, it's probably easier to pull that greatest common factor out to start. So every time you should look and see, is there a greatest common factor I can pull out first? And in this case, it's a 3. So if I factor out a 3, then 21 divided by 3 is 7. So I have 7n cubed. And then negative 9 divided by 3 is a negative 3n squared. Negative 21 divided by 3 is a negative 7n, plus 9 divided by 3 is 3. Now I still have 4 terms in here, so I'm going to go ahead and factor this by grouping. So right here, I can pull out an n squared. So I have n squared, and then I'm left with 7n minus 3. And then here, this is a negative in front, and I don't ever want my variable to be negative, but there's no number I can really factor out of 7 and 3 besides a 1. So I'm just going to factor out a negative 1, and then I'll be left with 7n. 3 divided by negative 1 is a negative 3. And I still have my 3 poking around on here. So now my parentheses match, which is a good sign. So my parentheses, I have 7n minus 3, and then I'm left with n squared minus 1. Now, if this were n squared plus 1, then I wouldn't be able to factor it and I would be done, and this would be my answers. But if you notice, this is a difference of squares, just like we factored earlier in the problem, so this factors even further. So I'm going to go ahead and do that on the side. So n squared minus 1, I don't have a b, so my b is 0. So then I have a times c is a negative 1, and b is 0. So two numbers that multiply to negative 1 and add to 0 are 1 and negative 1. So this factors to n minus 1 times n plus 1. So if I come back here, I should have 3 and a 7n minus 3, and then an n plus 1 and an n minus 1. So I'm going to go ahead and look at my solutions. I know it's not c, because that doesn't have a 3 out front. And then I need one that has a 7n minus 3, and A does, and then it has my n plus 1 and my n minus 1. So the order doesn't matter as long as all of them are included. So the answer to number 8 is A.